Okay, in this video, we discussed the 7 steps of hypothesis testing, and then briefly talk about, again, there are many different statistical tests. We're going to focus on one, and what that is inferring something about the population proportion from a sample. So here are the 7 steps. I have those. There's 2 columns. The column on the left tells you what the 7 steps are, and the column on the right are some additional comments about those. So the 7 steps, the first one is, the first 2 are together. One of them is establishing the null hypothesis, and the second one is establishing the alternative hypothesis. Now there's lots of different ways to write these depending on the type of test, but let's just talk about what they mean. The alternative hypothesis, or a lot of times that's just called the hypothesis. That's what you're trying to prove. You're trying to prove something. So the null hypothesis is what you assume to be true. You don't have to prove it. So if you think about a jury system, and in the United States, a defendant, what we assume is that they're innocent. The defendant does not have to prove anything. So the null hypothesis in that case would be that the defendant is innocent, and then the alternative hypothesis would be we're going to try to prove that he's guilty. So we've got a null hypothesis and an alternative. The third step is that you've got to establish what your type 1 error is, or alpha error. It is, by convention, usually less than 0.10. Some people use 0.05, sometimes 0.01. We've had a video before showing how you want to be careful about making alpha too small, because if you do, you're going to have a good chance of having a large beta. This is can be a very in-depth discussion, but again, by convention, usually alpha is set at less than 0.10. The fourth step is calculate the statistic, and again, the statistic depends on the statistical test, and there's many different stats from the statistic. And by the way, the statistic always comes from the data. You have data, and then you calculate the statistic from the data that you have, your sample. And after you calculate the statistic, you calculate something called a p-value. And the p-value's definition is the probability that the null hypothesis is true. That's what the p-value is. And we're going to calculate that, and if that's really small, if the p-value is really small, that means the probability that the null hypothesis is true is really small. So what's the definition of small? Well, we always define it relative to alpha. So if the p-value is less than alpha, which means the p-value is small, if that's true, then we're going to reject it. That means that the null hypothesis is probably not true. If the p-value is less than alpha, reject the null hypothesis. Otherwise, you fail to reject. If the p-value is big, and big is bigger than alpha, which we set in step 3, if the p-value is big, then all we're saying is that we do not have evidence to reject the null hypothesis. We generally don't say the null hypothesis is true. We just say we don't have evidence to say otherwise. And then the last step, the practical conclusion, is always stating the conclusion in step 6, without using statistical terminology. We don't want to confuse whoever the decision maker with stats. So you want to convert step 6 into a practical conclusion. Now the application we're going to talk about is a population proportion. And again, a proportion is just it's a statistic based on counting data. You use it when all your data is nominal or categorical. So if we would do a survey and ask people, do you like Coke or Pepsi? Then we would count how many people said Coke and count how many people that said Pepsi. And we could calculate a proportion statistic by taking, if we were looking at the number, if we're wanting to see if people prefer Coke over Pepsi, we could count the number of people that said Coke divided by the total number of people we ask, and that would give us a proportion statistic from the data. After we calculate the proportion statistic, we can calculate our test statistic, which is what we need in step 4. In this case, the test statistic is a z-value, and there it is. And we're keep in mind the p with the hat over it. It just tells you that that's an estimate from the data, and then the p without it is what you're assuming to be true. So we'll have all those numbers. It's a little complicated formula, but I'll show you how to do it in Excel. The most important part of this is that the statistic that is generated is normally distributed, as long as we don't have really small p's or really small data sets. If we have a decent size, and again, as long as n times p and n times 1 minus p, as long as both of those is greater than 5, which is not a lot of data, or then we can assume that z is going to be normally distributed. And we've already talked about how the normal distribution shows up a lot in statistics, and this is one place where it does. All right, so the next video we'll do an example with numbers. Thanks.